Okay, let's go ahead and get started. So thanks everybody for coming out today to this great event, and I see some folks I know have traveled from quite a ways over. Hopefully everybody is doing well and enjoying the content so far. So my name is Dan Kogan. I'm from Microsoft, and as I mentioned, I look after our analytics platform system Appliance and our integrated systems business in general. So today I'll talk to you about how we think about the data warehouse evolving and scale-out data warehousing and how that comes together with other technologies that are starting to play in here of something we call the modern data warehouse and an evolution we see happening for a lot of our customers. So I'll try to get through the content reasonably quickly, give us some time for discussion and questions, and I'll address as much as I can about current and future directions that we're moving. And if not, we go into lunch after this, and I'll be here the rest of the afternoon and happy to kind of take any private conversations or keep the discussion going. So before I jump right into sort of what we're doing and the technology of what our portfolio looks like and how everything fits together, I want to think about data warehousing a little more generally, and kind of where we are in the state of this industry and kind of what I hear from customers. So we've got this sort of picture that I think everyone in this room, having an interest in data warehousing or being a BI or data warehouse professional has been trying to get to for probably the last couple decades, really, as far as this notion of an enterprise data warehouse has existed. Companies have been spending lots and lots of time and money and energy trying to get to this point where you have that single source of truth, that one central EDW that has clean data in it, has a good collection of all of your data sources, it's performance tuned. Then your end users have BI that plugs into it. They have all the information they need at the tips of their fingers, quickly, reliably, cleanly. It's this perfect, fantastic state that, is anyone actually there or feel like they're there in terms of their data warehouse? Not so much. Yeah, a little bit? OK, that's good. I do. At our executive briefing center, I feel like I meet with customers and have a similar discussion 2 or 3 times a week. And it's amazing how much everyone has been trying to get this point. Technology is some part of the limitation. I think more and more of it, though, is just process and the ability to lock down a single source of truth. It's just in data into a single IT-managed enterprise data store. It's very, very difficult to get, at least in enterprise accounts, with multiple different business units, geographically dispersed companies, those types of things, being able to get everything bought into that. It's that same type of issue we had kind of with the spread mart hell and Excel-type problems beforehand, just exacerbated on the back-end side of things. So it's a challenge that companies have been trying, both customers and companies have been trying to solve for the last 20 years. And we feel generally we are at a point where a physical data warehouse, one central enterprise store where everything is going to reside is probably just not going to happen. It's a bit of an impossibility. And I'll talk about it for a few reasons and kind of why we see the market trending this way. But a quote in there from Gartner who sees it very, very similarly. So this picture here we'll say is our typical SQL Server data warehouse customer. Most are probably on 2005, 2008 R2. We've brought more and more data warehousing technologies like the column store and then the updatable column store into 2012 and 2014. But the vast majority of our customers actually aren't on those latest systems yet. And certainly, the vast majority aren't using our parallel data warehouse software, the scale-out version that's in the appliance. So a few of the issues that most of our SQL Server customers experience today, the first 2 are really, I would kind of call them old school data warehouse problems. But in terms of performance and scalability is really what you break that down to. So this is scaling out your SMP data warehouse or scaling up your SMP data warehouse. At some point, you kind of hit a point of diminishing returns in terms of how big you can go with your server, how much SAN you can put behind it, those types of things. So just your scalability is a little bit limited in an SMP world. And as data volumes are growing very, very quickly, more years of information is being stored for analyses, more types of information. Companies are having mergers and acquisitions and all sorts of things like that. Just scaling existing SMP infrastructure is a challenge. Second one on top of that is, because of all the rise of self-service BI and how much more people are doing with analytics and asking more interesting ad hoc types of questions, that puts a lot more pressure on the system as well to, one, have information be there in real time. So where we used to be able to do nightly batch loads of data so that it can be staged for processing and analytics the next day isn't really acceptable so much anymore in a lot of use cases. Now data needs to be loaded to the data warehouse at almost near real time as well, and they're getting queried as the data is getting loaded, and as people know, that's really what puts a lot of challenge onto a multi-purpose architecture like an SMP system that isn't necessarily designed for data warehousing. So that's why Microsoft, hearing that type of feedback, seeing our customers who hit a point where they couldn't go any further with SQL SMP, move to other MPP software systems like Netezza, like Teradata, others in the industry like that. We acquired Data Allegro, which was a PDW or an MPP software vendor that became SQL Server Parallel Data Warehouse, and that's kind of been the solve for those first two problems. And that's really who we built this product for, who we really cater to now, and as Nigel alluded to, the direction we're going is to make that migration from a SQL SMP to a SQL MPP as seamless as possible. But so those are issues that have existed for a very, very long time, and that's why MPP software has its place in the industry and as popular as it is for the certain type of use case. What we're seeing more and more now is, I'm going to call this the rise of Hadoop, really. It's not so much necessarily non-relational data. I think that's kind of where the heat around Hadoop started and what the primary use cases were. But most enterprises I talk to now are thinking about how they're going to use Hadoop in their infrastructure moving forward. It may not be for what we'll call the big data, right, or new data types. It may be for data archival. It could be for this concept of a data lake where you'll just throw literally everything into Hadoop and then figure out what to do with it later, those types of concepts. So most companies I speak with aren't exactly sure what they're going to do with Hadoop, but they know it's going to be part of their infrastructure. And so at that point, you already have a bifurcation of your data warehouse between the relational database, whether it's a SQL Server, a SQL PDW, some other RDBMS platform, or Hadoop. The two are now separate systems. So, and if that's the trend that we're going to see continuing, already you're past that point of one single physical structure that everything is sitting into. And now what we're seeing more and more of is data that's being born in the cloud, right? We talked about those IoT scenarios and all that data coming off of devices that's never even going into on-premises systems, but holds lots and lots of valuable and interesting information that you also want to analyze and start to build insights off of and combine with data that's on premises and existing systems. So the more we have systems like that proliferating, the harder it is to get to that single source of truth again. So from our standpoint and from what we see in the market and what we see talking to our customers, just having that one EDW in the middle that's going to be able to store data from all these different places, it's just not something that's going to be sustainable or scalable. And so we have to think about other ways of still getting to that notion. The concept is great of enterprise data warehousing. Everybody wants to get that single source of truth. But the infrastructure you take to get there, the tools you take to get there, we think are going to be a little bit different. So if I think about our modern data warehouse platform at Microsoft, it starts with SQL Server and Hadoop essentially sitting side by side. Those two elements we see as the new data warehouse. Not most customers, I'll say, are pretty early in the stages of maturity here, not necessarily using Hadoop in production. It's certainly not the central piece of their data warehouse strategy, but it's coming more and more. And so we're expecting that it's going to live within their data warehouse environment next to the RDBMS in a complementary fashion. I think that's another trend we're seeing, is that most companies aren't moving away from relational data warehousing to Hadoop. And the more people are using Hadoop, the more they're understanding both the benefits and limitations of that system. And that it makes a lot of sense in a model where you're leveraging both systems for what they're good at, but not necessarily looking to replace your entire data warehouse infrastructure with Hadoop for a variety of reasons. But I was at Hadoop World a few months ago. It's probably about 6 months ago now. And analyst from Gartner was presenting some of his findings that he surveyed a set of customers doing big data projects using Hadoop in 2013. And about 10% of the customers surveyed said, we think Hadoop will replace our existing data warehouse at some point in time. We'll be able to turn off our Teradata, our SQL Server, whatever it is, and go full scale onto Hadoop. A year later, same set of customers, Hadoop has matured more, everyone's done more with it. That number went down to 5% that thought they'd be able to get there. So I think as as this industry is maturing and people are seeing benefits and limitations, it's changing. But the point being is still, though, that these two systems are going to have to coexist. Then as we have things like SQL database, blob storage in Azure, other data stores that exist beyond these two that we have here, even other NoSQL stores or other engines, the number of systems in that data warehouse is just going to grow. So how do we get to an endpoint here where the end user is kind of at the top of the slide, the people using Power BI or the people using other dashboarding capabilities still have a clean single source of truth and a way to get to integrated insights without physically bringing all the data into one container that the BI tools point to? For us, that's the single query model, which is PolyBase. And so that was discussed a little bit earlier in Nigel's keynote. It's part of the APS appliance today. We plan to expand that, make that part of SQL v Next, as they alluded to, and open up that door to more and more implementations. But the key with PolyBase is it integrates querying across SQL Server, and today Hadoop, tomorrow could be other things, right? But that's the vision of where it will evolve to. And the vision we have for that technology and the message for our customers really is continue to focus on really understanding SQL Server deeply and investing in SQL Server. We'll do the work on the back end with a capability like PolyBase to bring together data from SQL Server and your query in SQL Server with the data from other systems that are becoming important systems of record and systems of information. So we'll jump into what are some of the challenges that our customers experience today moving from their existing data warehouse infrastructure to this modern data warehouse infrastructure that can scale quickly and do real-time analytics and bring Hadoop into the equation. There's typically some sort of legacy component, and it's very, very, as people know, very painful and very challenging to move away from legacy, whether it's costs that have gone into software or hardware, but even more so in skills and what people are actually good at and being able to do. So those are challenges that that customers have moving from what they're doing now to moving to what they're doing in kind of a new world to support this. There's systems like our APS appliance that are designed to integrate Hadoop and relational data, but in most cases they're very, very expensive. We think we have one that is not. And then adding BI on top of that. So good points were made about limitations of Power BI and limitations of Excel, but at the same time, adoption of other BI systems is very, very low, and I think this is why there is so much popularity for the self-service BI trend, is that at the end of the day, it's about getting information to the hands of as many users as you can, and Excel and Power BI are very, very good tools to do that, in addition to other things like Tableau that plugs right in. So we think with APS, we have something that solves these challenges extremely well. So what it is, if folks don't know or haven't heard yet at this point, it's a appliance, so a fully integrated system, hardware, software, pre-installed, networking, storage, switching, everything together in one package. Not a lot of customization enabled with that. Really, the only thing you can do is choose your hardware vendor and your size of disks for storage, 1, 2, or 3 terabytes. Beyond that, it's essentially a fixed package. But the benefit of that is it works very well for what it's designed to do, which is high-scale, high-performance data warehousing. It's not made for scale-out OLTP. It's not made for general-purpose SQL virtualization, consolidation, things like that. It's a data warehousing analytic system. That's what it does. That's what it does very well. But it allows for linear scale-out, both in terms of storage and performance, into the petabyte range, as Nigel was alluding to earlier today. It brings in that MPP element, and we'll talk a little more about kind of benefits of MPP versus SMP as I get in the slides. It brings Hadoop into the appliance itself for customers that want to have something into an integrated system, but that's not a mandatory design element, and PolyBase being the key isn't necessarily tied to the Hadoop distribution running inside of the appliance. The key there is PolyBase, which is what brings together the relational and the non-relational data into an integrated fashion. I'll talk a little more about that. So let's start on the big data side of things and how we try to make Hadoop enterprise ready with APS and what we're doing here. So Nigel talked about those 3 V's of data: variety, velocity, and volume, and data kind of growing across its axes. when I think about it on this sort of perspective, it's really why people are doing big data, why they're looking at all these types of different data types, data sources, dealing with this. It's the value of what you're able to get into that data. Moving from the most basic thing, which is kind of historical reporting and looking at your past transactions, to the point where you can do really interesting predictive analytics scenarios like Nigel's talking about with the connected cows, and doing those more types of things for your relevant business area. That's why we're all here. That's why we're working as hard as we are to get to these types of systems. So, talk about Hadoop really quickly. Do most people know what Hadoop is at this point? Okay, so think of it as a distributed file system at the most basic level. It's a way to store data using this HDFS file system in a scale-out fashion, originally intended to be done across commodity hardware. So there's nothing really fancy about it. It's open source software, so the software has no cost. And it was started by internet companies really taking data in the petabyte scale that needed a better, more cost-effective and efficient way to store it. So able to scale out data, able to scale out your storage across an infinite amount of servers at a very, very low cost, which allowed you then to collect and analyze large volumes of data. It has its own programming language. With SQL Server, we have T-SQL. With Hadoop, we have something called MapReduce. And since the ecosystem has grown around it, there have been other tools to make it look and feel more analytics-like Hive for structured data querying, and Mahout for more advanced analytics and predictive scenarios, and lots of other fun terms that come out of the open source software like Zookeeper and Flume and all sorts of fun things like that, Pig. But at its most basic level, it's scale-out data storage. It is designed for low cost and infinite scale. It is not designed for performance. And that's that point that customers are seeing the more they get into it, is queries take a very long time to process in general on Hadoop. And when you start to do very complex ad hoc queries, they don't process at all, which is where you start to really understand some of those limitations and come back to needing a model that blends together Hadoop with a relational data warehouse engine. So the challenge, though, of integrating that in with what you do, it's a physically separate system now. So part of it can be you keep data in two places. You start training your workforce to understand how to work in Hadoop, whether training them on MapReduce and using that computing language, or working in that kind of dual world. That's a challenge from a people skill set perspective, and you also have your data in two siloed places. Another thing you can do is move data from Hadoop into your relational data warehouse, at least the data that fits into a tabular models and structured format. But the challenge with that is when you move it over, you're obviously taking up more storage and space in the RDBMS, and you're losing that cost advantage of Hadoop. So neither one of those is really an ideal scenario. So what would be perfect is to query the data that's in Hadoop using a skill set you know, like T-SQL, and do it while the data sits in Hadoop and doesn't actually have to move over. So that's a nice setup for what we do with PDW. So PolyBase is that capability that allows us to do that. But at the same time, even getting the skills to stand up Hadoop and to build your own Hadoop distribution isn't something that most IT departments or staff for today. That's where companies like MapR and Cloudera and Hortonworks really make their living, as the software itself is open source and isn't something that's monetized, but it's the consulting around it and the enterprise resources and support and things like that. So that's what those companies deliver. We provide some of that convenience in our appliance form factor. So here, the APS appliance itself really kind of starts with SQL Server PDW, that MPP build of SQL Server at its core. But you're able to add a Windows-based version of Hadoop data, of Hortonworks data platform to the appliance package. So that's what, when we say Hadoop here, that's all it is, Hortonworks data platform for Windows. Comes preloaded, comes pre-installed, can be monitored through System Center like everything else in the appliance with the PDW workload, can have Microsoft support across it. So it's really a convenience factor. I will say this is not what most customers do. It's not the cheapest way from a hardware perspective to deploy Hadoop. The APS hardware is relatively cost effective. Well, it is the lowest cost for any data warehouse appliance, but it's more expensive than just your basic commodity servers they might have laying around. but it's a convenience from that standpoint with Hadoop to bring it in there. But most customers have started their own Hadoop distribution. They have something they've done before, and now they're trying to find a way to integrate. And so that integration is really the key, and that's what PolyBase really delivers. So something Microsoft does, it's very different than any other vendor offering a integrated Hadoop and SQL-like querying interface or combining Hadoop with the RDBMS engine is we're generally agnostic around what Hadoop distribution you're running and where you have it running. Microsoft doesn't care. So we put Hadoop in the appliance as a convenience, but we monetize next to nothing right here. So if our customers order Hadoop inside of their APS appliance, the only people really making money on that are HP and Dell. To Microsoft, it's a convenience because we see our customers needing Hadoop as part of their modern data warehouse, but it's not something that we really care if they run in our appliance or not. Most will have external Hadoop clusters running with Cloudera or Hortonworks, who are the two market leaders, probably running on Linux, as that's what the vast majority of Hadoop clusters are built on, and that's fine. We've designed PolyBase to work in that environment. Others will run Hadoop in the cloud, in our Azure cloud, and a product we call HD Insight, potentially hosted in Amazon or other clouds. That's okay as well. So the key for us is that PolyBase can reach into those Hadoop distributions. Nigel talked about a little bit and how essentially treat Hadoop as an external table to SQL Server, and then do truly federated integrated querying against it. So the way that works in practice is Hadoop is set up as I said, as an external table. User sends a T-SQL statement to SQL Server, which is what all the BI tools are pointed at, the whole ecosystem sits at. PolyBase will convert that T-SQL statement to MapReduce, go over to the Hadoop compute nodes, understand what data it needs to process them on Hadoop, and return an integrated query set. So it's not moving large volumes of data over into Hadoop, it's doing all the work through the tooling. And so the benefit is the Hadoop data gets to live where it lives and gets processed where it lives, and users get to use the skills they know, which is SQL Server, but the people using the BI tools get an integrated picture. That in a nutshell is our vision for modern data warehousing or logical data warehousing right there. So today what we've built works against Hortonworks and Cloudera clusters for Hadoop. I'm sure MapR will get added sometime before too long, and that essentially rounds out the industry of major Hadoop vendors. But I think the vision, as I said, is very much this will go beyond just Hadoop, and it will talk to the next Hadoops, the other systems there. So it's something we'll continue to invest and evolve on for quite some time. So the key here then is why you have data in these systems and who you're trying to open it up for and what APS enables there. So if you're looking at the people just accessing Hadoop, it's relatively few and a very specific skill set that not a lot of people have today. So that's your data scientists. Obviously, a lot more people familiar with analysis services and using cubes and things like that. But really, the masses and the people in Excel and the people in Power BI are just consuming all that data that's been prepped for them, leveraging these systems. And so by abstracting the things like Hadoop and bringing that together, you're able to give them access to all those different types of data without actually having to throw them at multiple tools or multiple reports. So one of the things Nigel alluded to as well that we've done in APS is recently have shipped direct connectivity between Power BI and APS in the appliance. So there's something called the Data Management Gateway, which creates a secure connection between your on-premises data sources and Power BI and then allows direct querying. We've shipped that component on the APS appliance. So it's pre-installed, it's ready to go, just like everything else on the appliance there. So it enables that connection enables a secure on-premises data hub for your cloud BI asset. It's one capability, it goes around, and it's really anything with a no data feed. So that'll work for Power BI, that'll work for Azure ML. Part of the importance of this really is illustrating, though, to an earlier point Nigel made as well, is that we see the APS appliance as the vehicle that can create this logical data hub, and then we're going to continue to light up other assets, some of them in Azure, some of them on-prem, but this can be the vehicle to connect those types of things. So we don't see everything we're doing in cloud being mutually exclusive from everything that we're doing on-prem, and most of our customers' data is still sitting on-prem, and they're not moving their data warehouse to the cloud. They don't want to move their BI tool into the cloud necessarily as quickly as we might like them to. So it's finding ways to use the cloud to benefit everything that's happening on premises. And so that's really a key for the future of the APS appliance and how this is going to continue to evolve. So this is a proof point now. But I'll go through a customer story in a second that will show more of these types of hybrid use cases and worlds. So before I jump in the customer example, I'll talk through one other case study we have. So this is Shinsegae, who's one of the largest is the largest retailer in Korea, one of the largest retailers in the world. Made a business model transformation, moving from being predominantly a brick and mortar based retail store operation to an e-commerce business. They want to be the next Amazon of Korea. I think every retailer probably wants to be the Amazon of their specific country. But to go from brick and mortar and the way you do operations in that type of a world to predominantly e-commerce requires really not just a change in business model, but a change in interaction and how you understand your customers and what you're doing. So if they want to be able to do predictive analytics and serve up their customers' next logical purchase and really, really understand their customer sentiment around their products and around their sales experience and everything else and really be very customer centric, that involves collecting data and storing data that they never had to do before in an old world. Right, so they're doing things like they're mining Twitter very, very actively to find out not just sentiment of customers around the Shinsegae shopping experience, but around all the brands they carry in their stores. So they know, and then tying that with customers' buying behavior so they can understand if you are a fan of this brand, you'll be a fan of this brand. And we continue to kind of sell and evolve. So what that's done is that's required them to keep vast amounts of information, now at 450 terabytes, that they deemed to be something that was not cost effective or that they wanted to keep in SQL Server, in RDBMS engine. So they kept that in Hadoop, in a cloud era Hadoop cluster. Then they tried to do some analytics against it and tried to do some pretty complex ad hoc stuff that their end users or their business analysts were used to doing, and the queries just weren't processing. Some took hours and hours to go, others just fell over. So they start to see Hadoop alone wasn't really working. We need to have some kind of option that blended these things together. They took a look at some of the other systems on the market, but it almost, in some ways, they were almost led to APS by default because we were the only vendor on the market offering a capability like PolyBase that was agnostic to the Hadoop distribution. If they wanted that from Oracle or they wanted that from IBM, they were going to have to move off of the Cloudera distribution they already built into another appliance specifically built for that, then connect it up to an Exadata or connect it up to Netezza. That wasn't a route they wanted to go either. So the flexibility they got through APS was something that allowed them to sort of reach that new business model. So and they've been very happy with that since. But I'll talk about another company. This actually case study just went public. This is a company called Ziosk, who is a startup out of the US. What they build are, they don't build the tablets, but they build software that runs on small tablet devices that gets put into restaurants. Think of, it's a US chain called Chili's. That might be around some other countries, but also places like Hard Rock Cafe and companies like that. So they put a little device on your table. That device allows you to order food. Also allows you to order songs. So it's a little music player, play games. All sorts of things are happening and having a more interactive dining experience. So lots and lots of data, again, being created out of these systems that it would be very interesting for this company to analyze. So it's a young company. They don't have a lot of money to spend on infrastructure. They don't have a lot of legacy infrastructure. And their data volumes are growing very, very quickly. So, and generally a lot of cloud-borne data coming through as well. So, and their skill set was around SQL Server. Their existing environment was built on SQL 2012. So that's how they began. So what did they do? So they looked at two paths originally. So one was to go 100% cloud. Let's look to SQL VMs in Azure as the way to go to start out. So they didn't consider SQL database. They wanted SQL Server VMs in Azure. looking at analysis service on top of that, Hadoop in Azure, BI tools in Azure, 100% Azure scenario as one scale-up path. The other was to do some of that on premises, some of that in the cloud. So scaling up with SQL Server 2014, and then everything else in Azure. So those were sort of the two things they looked at. But they brought in a Microsoft kind of gold BI partner, a company called Artist Consulting in the US, who helped them with their business case and their evaluation and said, hey, you guys should look at a third option, which is this APS appliance. Let's just look at the whole Microsoft stack and kind of see what's the right fit for you. And so they did a 5-year TCO. And what they found was, in terms of how their data volumes are growing, how they want to structure their infrastructure, their 5-year TCO is actually significantly lower to go with the APS appliance for their relational data, everything else in Azure. So there was a slightly higher upfront cost, as you can, we're not deep in the numbers, but you can see there's some physical acquisition of hardware and software that happens here. But then once they got to that point, things dropped off precipitously. This was, again, they were expecting to purchase another physical appliance as their data volumes jumped again. But for the most part, their TCO is going to be a lot lower that way. So that's what they ended up going with. And the semi-complex picture is what their overall infrastructure now looks like, or their architecture looks like. So these are the devices that are sitting at the restaurants, and the data is going essentially into two places. You have data going to Azure Blob that's sitting in HD Insight in Azure, and that's kind of, we'll call it a data lake. So everything sits in here, and that is a vast morass of data, some of it useful, some of it not useful, but at least it's all going to go here and it's going to get figured out later. For more of the near real-time analytics and complex analytics, they move data over into the APS appliance that sits there. They put analysis service on top of that, point their end users and the vast majority of their people doing BI, doing analytics queries to this engine. So they split it a little bit where they can take a subset of users, the data scientists, the people that kind of want to look at everything, do some more experimental analyses. They keep them at Hadoop. They put everything else into PDW and kind of leverage a mix of on-prem and cloud systems, use PolyBase to integrate data from the two, point their BI tools at PDW or at APS, and that's essentially the infrastructure they've gone after. At the same time, they're able to age data anytime they want to out of the data warehouse, back up to the Hadoop store into Azure. That's another one of the scenarios and kind of hybrid things that's supported. So it was an interesting way to go about it, and I would say this is probably the most common way we're seeing companies using Hadoop in concert with their relational data warehouse, where Hadoop is the vast store for everything. It almost becomes the ELT zone, if you will, in a way, that everything's getting loaded in there, and then it's getting cleansed and processed and picked apart on the Hadoop layer, and then it's making its way into the data warehouse for analytics. And then Hadoop is being, you can back up data from the data warehouse to Hadoop as well. So in summary, they looked at a few different options, all of which could have worked for them, but weren't decided one way or the other. There was no push that you had to go all cloud, no push you had to go all on-prem. Just looked at the best options and found a hybrid infrastructure worked really well for them. So it's a good story and something worth considering. So now getting into the performance aspects of an MPP data warehouse and the APS appliance. So two things, as I said, most of our customers are still running 2005, 2008 R2, haven't necessarily taken advantage of capabilities like column stores, which by storing the data in memory in a columnar format dramatically increases the query performance. And we've seen first from 2008 R2 to 2012 with the read-only column store, then the clustered updatable one that came in 2014. Just orders of magnitude better performance on certain types of queries, which is great. But it still also hasn't changed the aspect of scaling up in data warehouse and forklift upgrades. So you're working with HP, you've kind of hit the limits of what you can do with your DL360 server. Now you're into backing up your data. You're bringing in a 580, a new SAN, loading data back up, performance tuning, balancing, doing all those types of things, and you're into weeks or months until you're cut over to the new system. So that scale-up approach still is relatively time-consuming. So those are two of kind of the legacy issues a lot of our customers deal with today. So what we bring with APS, first on the scalability standpoint of it, is essentially this pre-built system, and if you order it, you get this nice big cabinet, and it starts with 2 compute servers here, and some scale and a control and failover servers kind of at the top. But ultimately, it's an empty cabinet that you can, with the exception of your base 2 compute servers and storage, and then you can kind of scale as you go with PDW or with Hadoop. So relational data, non-relational data, or RDBMS versus Hadoop, and scale that out up to 6 petabytes seamlessly. So pretty large volume of scalability for SQL Server, something most of our customers haven't seen before from the software. And it's not only linear scale in terms of storage. So again, this whole world of backing up your data, bringing in new hardware, tuning, balancing, that type of thing doesn't really exist here anymore. So what happens when you've hit kind of your end of one of those scale units and you move to the next one, that hardware gets ordered, it gets plugged in, the data automatically redistributes, and then you're off and running in a couple hours in terms of scale out instead of weeks or months. So it's a very fast process for that. So it scales the storage capacity linearly. It also scales performance linearly. So as an example, if you have 2 compute servers here processing your queries, and it takes a minute to run a query, and then you add 2 more compute servers, you double the capacity, that minute is now going to take 30 seconds. If you want that to go down to 15 seconds, you'll add 4 more compute servers. So it's linear in terms of performance scalability as well. And so we'll talk about that MPP concept here, essentially, is how that works. So the difference and kind of the secret sauce of PDW is what we call this cost-based query optimizer, something that sees the data, automatically comes up with what is the most optimal query plan for that data, and breaks up the query to run across all the different compute servers that you have sitting on the appliance. So instead of one really large server processing the query, what it's doing is breaking it up into smaller chunks to run across multiple compute servers. That is essentially your difference between SMP and MPP, and it makes a very significant difference in data warehousing. So we think of OLTP and data warehousing as just databases being built for 2 different purposes. When I think of transaction processing, it's the same type of transaction happening over and over again, and you're trying to do everything you can to make that transaction go through as quickly as possible. In some ways, I think of it as kind of designing a car for Formula One. As you're going around an oval-shaped track, and you just want to get around that track as quickly as possible, but you generally know the path around the track, and it's going to go in the same direction. With data warehousing, it's almost the opposite in some ways, where you don't know the query that's going to come in. That's why it exists, is for asking different questions, and it's really up to what your end users are going to come up with, what questions your business analysts want to ask. So it's much less predictable in terms of the path it takes. It's almost like an off-road vehicle at that point, that it's got to be able to go here, turn directions very quickly, go somewhere else, bring data from multiple places back together. It's just a very different design, and it's not all about bare metal horsepower, the biggest server, the most SAN, things like that. That can work very well for that Formula One transaction processing type world. It doesn't necessarily translate to data warehousing. So more iron isn't necessarily going to mean better performance in the world of data warehousing. So this is why that software MPP architecture really does make the difference by breaking up the compute across these multiple servers and firing that way. When you combine that with the in-memory column store, you start to see really fast performance and really good performance around data warehousing. So vast majority of our APS customers have come off of SQL Server to some extent. What we actually find it's very rare that I would say a customer has invested 10, 15 years in a Teradata system or an IBM Netezza or some other big kind of expensive tier 1 data warehouse appliance, and they just cut over the next day, throw that out, and move over to APS or move over to any other one. These are usually, there's a lot of time and effort and money that have gone in these types of systems. What we do see very often are customers that have those MPP data warehouse appliances in place, and they've had them in place for a long time. They also have SQL Server in place. Obviously, as we know, no one's, I think, 100% heterogeneous in their data warehouse environments, or at least in large enterprises. But when they start to use SQL PDW and they see what it can do, they start asking the question of, do I need to keep investing in some of the more expensive MPP systems, or can I actually see if SQL Server can carry over and do this for me? So they they'll hit their limit with SQL Server and what they can do with SQL SMP. They try PDW, they like PDW, and then they start to question if they can turn off other systems they may have around and migrate to this over time if the cost advantage makes sense. But so the reason we see customers at least moving from SQL SMP to PDW, even 2014, are kind of for a few factors. That first one, as I talked about, that MPP design and the ability to distribute data and data, both querying and data loading across multiple servers. That's just something we can't do, at least without a lot of work and tricks that most people don't do with SQL Server today. They find the actual integrated cost of the appliance with pretty low-end storage that's built in there, so it doesn't need an expensive STAN or things like that, ends up being a very, very compelling cost equation for them, better oftentimes than kind of building their own infrastructure. The linear scale out is another advantage that, again, you're not able to do with SQL 2014, a lot less performance tuning, and then the integration with PolyBase. Those are sort of the things that to a lot of SQL Server customers say, okay, interesting stuff. I'll look at this new version of SQL Server and take a look at it. And that's kind of how we think about it. It's not a competitive product. It's a complementary product. We actually made a licensing change relatively recently as well, where we've made the SQL Enterprise Edition as a license is fine to run on the APS appliance. So it's still a separate build of SQL Server. It's still SQL PDW. It's not SQL Enterprise Edition, but we remove the need to acquire a second license if our customers don't want to. So our top end is adding more value to the SQL Enterprise Edition SKU. But so it really just becomes the choice then of what's the right system for you as a customer to be using. Is it the SMP? Is it the MPP? Does the appliance model make sense? And we see then a lot of case studies like this. This is a very, very typical one. MEC is a big media company doing lots of web trend analysis, clickstream analysis on what their customers are doing with the ads they're placing, and then providing that back as a service to their final end customers. So quotes like that are very, very common, where queries run for 3-4 hours. They see them now being completed in seconds or minutes based on the way the data gets distributed and run through the multiple servers. And we have been extremely focused on making the migration from SQL SMP to SQL MPP as seamless as possible. Nigel talked about that a little earlier. It's not one click. We'd like it to be. Maybe it will be one day. That one day is probably not too soon. But there's a lot of tooling that we've come out. We've, closed a lot of T-SQL language surface gaps that existed between the products from when we made the Data Allegro acquisition to where we are now. It's been about 5-6 years. But also tooling that we've built in and are putting out to the market in open source to continue to evolve and find an easier way to migrate, automate a lot of the scripts and things like that. So finally, we'll talk a little bit about the value equation of this. We tried that to be a key tenet with Microsoft. So we commissioned a survey or an independent research firm to kind of look at the total cost of ownership of data warehouse appliances. So that's Exadata, that's what was EMC is now Pivotal, IBM Netezza, Teradata, and APS, and found significantly lower price per terabyte with the APS appliance than any of those other systems offer, at least in their published list pricing. And there's things we do to drive the cost down as much as possible. So this is a benefit to Microsoft not being a hardware company, in that our interests aren't around the higher end pieces of hardware. It's really around using the software to optimize as much as possible and create a compelling proposition. So what's some of the benefit around having everything together in a single appliance, both Hadoop and the data and the RDBMS layer? It's a reduced footprint in the data center itself, so you're not having to have multiple systems. You can have that all in one cabinet. Your time to value is fast. The integrated support model is a key piece here as well. So whether it's a single appliance with just an RDBMS, whether it's an appliance with Hadoop, Microsoft can take frontline support for all those things. A lot less work you have to do on the tuning side, performance tuning, management, all those types of things. So all leads to lower costs at the end of the day. So as we said, having that together in an appliance that comes from our hardware partners has value as well. So we have worked over years very, very closely with HP and Dell to optimize the system around the different kind of hand-selected components from both companies. So you're taking the best of HP's engineering expertise or Dell's engineering expertise, put with the best of Microsoft's, and that's the package you come out with. So you could, in theory, try to build your own with not the MPP software, but with your own SMP software. But once customers have looked down that path and looked at the time and the cost of it, it's usually not an equation that really makes a lot of sense. So there's a benefit to having everything integrated and having everything ready to go out of the factory. And as I mentioned, support is another kind of key aspect here, where even though there's two different parties in the acquisition of it, there's a single integrated support model all through Microsoft. So you're able to, doesn't matter what the problem is, you're able to call Microsoft. Our support rep will understand, diagnose if it's a hardware issue, it's a software issue, and they'll triage and bring out the right parties kind of behind the scenes to resolve it. But so having that type of white glove experience is really key for us. I'll talk a little bit about the architecture. So we see these are essentially compute servers. What I have here is an example of an HP appliance. Dell is very similar, with the exception of a third as one less scale unit, but with more servers. So these HP scales in blocks of 2. So that's the parallelization that comes from the 2 different compute servers. Those are just DL360s. In the Dell case, it's 3 compute servers. So Dell's will have 9 compute servers in cabinet. HP will have 8. Things like high availability, though, are also built into the appliance design. So with every appliance, there's a spare failover server that comes built in. So if any type of if a disk breaks or anything happens to one of the compute servers, the data will automatically fail over into the spare, and you don't see it, right? So there's very little downtime. So capability like always on doesn't exist here because we do high availability differently, but we build it in the appliance design. And I think we're yet to run into an issue of both the failover and another server going down. So not a problem we faced yet. But so that's kind of how we think about that. And then there's things we've done on the software side, as I mentioned, to bring down the cost of the appliance and really drive it into being a cost-effective model. So in our first version of the appliance a few years ago, as an example, it was always 2 physical racks. Even if you weren't using all the compute servers, there was one rack for compute, there was another for control and storage using a pretty expensive SAN. With the next version of the appliance, we used Windows Server storage spaces to eliminate the need for a SAN, so we could do just low-cost JBOD storage direct attached to the compute servers. Cut down on the cost of the appliance by about 60% from a hardware standpoint between the version 1 and the version 2. So as we continue to evolve on the software, we'll continue to look to ways to drive down the cost of the hardware and really get as efficient with those types of things as possible. Yeah, I saw a question there. So question was, is the license based on compute nodes or the appliance box? So licensing is per core. So it's per core on compute nodes, and that'll determine how many you can get in the box. So that's a little more about the that design. I will say the only thing in here that I would even consider a really high-end component, is the InfiniBand networking in there. So for high-speed data transfer within the appliance and within your data center. Other than that, it's all very, very commodity. So in this example from HP, the compute servers are DL360s, ProCurve switching, JBOD storage, very, very commodity components, which is what helps get the price down. But because of the software, the performance is still very good. So a question in the back? Mm-hmm. Right, so I'll repeat that so folks can hear and it gets on the recording. So, right, it is licensed per cores only on the compute servers. So each one of these servers has 16 cores. 2 compute servers is the minimum that we have for the parallelization. So you're at a minimum of 32 cores. That's the entry-level sort of software footprint stamp, and then jumps by another 32, and goes on from there up to I believe 56 compute cores. that's one. The other point that the gentleman in the back was making is the cost for PDW licensing is about 20% less core for core than cost for Enterprise Edition. Reason being for that is, as I said earlier, PDW does one thing. It does data warehousing. It does that one thing very, very well, but it isn't the Swiss Army knife that Enterprise Edition is. So we brought the price down a little bit below Enterprise Edition. But a lot of customers, most of our customers have already built their data warehouses on Enterprise Edition. They may be current on SA on Enterprise Edition, and if they're going to turn off one data warehouse, move over to the APS appliance, they were asking the questions, why do I need to go buy another license then, especially one that's cheaper? Can't I just move this license to that one? And we finally said yes. We typically always said yes through some exceptions. Now we've just made that programmatic. But for customers looking to just buy the data warehouse, it is actually cheaper core for core than Enterprise Edition is. And so this is a little bit of a chart of how the scalability works. I've just put, again, HP up as an example. But so we go anywhere from 2 to 56 compute servers, take a typical sort of a 5x compression ratio, and we can be anywhere from, this is the raw disk space in the 1 to 3 terabyte range. There's also a 2 terabyte option, but can go anywhere from essentially, with compression, 53 terabytes to about 6 petabytes of data storage. As I mentioned, both the performance, both the storage scalability is linear, but also the performance as well. So it's not all about the volume of data that you have in there, but it's how fast you want it to go in a lot of cases. So even though customers may not need terabyte or petabytes of storage, they may want to process data very, very quickly, so they'll just add more compute servers to do that. And so the final case study I show is, I'd say, a very common one. Again, it's that perfect example of someone who was using SQL Server. They got to a point with SQL Server SMP where they didn't think it would work for them anymore, so they looked at their MPP data warehouse option and chose PDW. So Royal Bank of Scotland, I think they presented at the Gartner BI Summit in London last year with this story, but their analytics division used SQL Server. The bank more broadly used Teradata as their MPP standard. So this analytics division said, we're using SQL Server, we're on 2012, queries are taking far too long for us right now. Typical queries on average, and again, pretty complex stuff coming out of an analytics group, but queries on average were taking 3 to 4 hours to run. Some of their more complex, like end of month statements, would take 3 to 4 days. They'd have to have people from the team on site 24 hours a day to make sure that query processed all the way through. So they were seeing that being untenable. So they looked at 2014 with a better column store, didn't see enough of performance improvement, and said, okay, at that point, we're going to have to go MPP. The bank owns Teradata. That's a good option to use. We should go that route. The Microsoft account team said, give PDW a try. Just do a head-to-head proof of concept. See where you go. Take it at that. So they found better performance on PDW, not orders of magnitude better, but still on most of their queries about 7 times better performance. And it was a 2-year-old Teradata system versus a brand new APS appliance. So maybe some advantages in the more current hardware, but still performance was slightly better. The big thing though for them was it was 85% cheaper to get a new PDW than it was to pay essentially the fractional ownership part of what they would have with Teradata. So that became, at that point, kind of a no-brainer for them that it's performing better, it's the skills we use, it's a fraction of the cost, I think I'll go this route. That's basically our typical APS PDW customer. It goes through that exact same journey, exact same question, and then they start to see, do they really need to continue investing in some of the other MPP systems they have? Obviously, those make sense because they have data models built around them and lots of infrastructure and reporting that sits on top of them, so it's never a overnight cutover, but they can start to really, really challenge the notion that they have to continue to scale out on some very, very expensive systems, most of whom at this point are actually not really adding a lot of new customers, but are making most of the revenue off the maintenance of existing ones. So it's a question a lot of our customers are asking. So wrap things up with that. We see PDW really as that turnkey modern data warehouse appliance today that brings together everything you need for big data with MPP capabilities and an in-memory column store, and doing it at a very cost-effective price point. So more information on the website. I'm sure all the folks from Microsoft here happy to share more as well. I think we've got about 5 minutes for questions, but then I'm happy to run over and stay after. Sure. Yeah, so question is, PolyBase generates MapReduce jobs. Is it gonna replace the TES? Is that essentially it? Yeah, it will. I think it will support TES down the road. It doesn't today, but I expect that to fully come online. So can you repeat the question? You said multi-dimensional, yeah. Uh-huh. That is a good question. That I don't know a specific answer to. So I'll come back. I can actually talk to Rohan. His team owns the engineering behind it. I know that question's been asked a few times. I think it's one of those things that will probably get addressed down the line, but it hasn't been one of the loudest pain points, I think, for most of our customer base. Sure. You just take that offline? Okay. Okay, so the question was how to essentially buy APS. Is that more paraphrase it? Order hardware from HP or Dell. The licenses actually come pre-installed on that machine. I'm sure if you're a managed customer Microsoft, you'll have an account manager and these solution sales specialists that focus on SQL Server and other technologies. We have, in addition to those people, APS specialists. I'm sure they will be happy to let you know what licenses you have to reuse or have to buy. But it's essentially it's adding to an enterprise agreement, like any other, like SQL Server Enterprise Edition. No, not in Azure. PolyBase will surface. Well, that's a separate question. What he was talking about was PolyBase surfacing in SQL vNext box product. So that's fairly consistent. So like the updatable column store that's in SQL 2014 was in SQL PDW about a year before. So we like to use APS as a way to innovate new data warehouse features, and then once we think it makes if we think it makes sense to take to the box product, we bring them in the box product. So I think more and more you'll see going there. Yeah, I think that's actually a very, as we see more usage of Data Factory, I think that's exactly one of the types of scenarios we're going to see more and more. I think so. There's nothing in here that's not NDA, or that is NDA. So I'm not sure how to make them available, but we can talk to Lars Boe about that. Otherwise, we'll find a way. I've got them on a memory stick. If you want, just copy them over. So we'll figure it out. Okay, great. Oh, sorry, one more question. Uh-huh. Rollout, exactly. And yep, and roll app and those types of models. Yes. Short answer is yes. I think that's a relatively common reason customers will start to go look down that route. Okay, super. Thank you guys for staying through, and enjoy the rest of the conference.